Thanks for joining me today. The goal of this webinar is to expand everyone's understanding of the various ways that telemanipulators can support radiopharmaceutical production. During our time together, we will cover the origin of telemanipulators, their connection to the radiopharmaceutical industry, ways to customize your telemanipulator, and then I'll be joined by Rob Weber for a roundtable discussion just before our Q&A session. I'm Kyle Bear, Sales Account Executive with Central Research Laboratories, or CRL. And later in the webinar, I'll be joined by Rob Weber, CRL's Projects and Proposals Manager. He's held several positions over his 30-plus year career with CRL after earning his bachelor's degree in aerospace engineering and mechanics from the University of Minnesota. When you have questions about telemanipulators, you want someone like Rob in your corner. So I'm glad we have him today. CRL is a manufacturing and engineering company based out of Red Wing, Minnesota. For over 75 years, we've specialized in remote handling solutions to keep operators safe and to help maintain hazardous and sterile environments. CRL solutions support nuclear and life sciences industries and span categories like transfer systems and glove ports. But today, we'll be focused on the category that put CRL on the map, telemanipulators. During the atomic era, it became critical to improve our ability to safely handle hazardous and toxic materials produced by the nuclear industry. Consequently, in 1950, CRL built its first telemanipulator, the Model 1, under the direction of Ray Gertz of Argonne National Laboratory. Ray was the inventor of the very first telemanipulator. This innovation answered the need so well that it became an essential tool to assist nuclear scientists in their research and development of atomic energy. A telemanipulator is a mechanical arm that allows a person to remotely pick up and manipulate objects. It serves as the hands inside the hot cell for operators outside. As you can imagine, since 1950, telemanipulators, or manipulators, as they're often called, have evolved quite a bit, and they've made their way into the mainstream with appearances in movies such as The Incredible Hulk and The Andromeda Strain. Today, manipulators are still used heavily in the nuclear industry, and they've made their way into other industries like radiopharmaceuticals. CRL isn't the only company involved. You can find manipulators built by others like True Motion, Lachlan, and Welschmiller. Let's take a moment to examine some of the impressive work that you're all a part of. Where there's diagnostics or therapeutics, there's literally life-altering work that's being done in the radiopharmaceutical space. Categories like neurology, cardiology, and oncology, just to name a few, are all positively impacted by advancements in radiopharmaceuticals. This is an industry that's growing and forecasted to grow at a nearly double-digit rate. Analysts are predicting growth rates of 8 to 9% over the next 5 years across the world, with the US being a big driver. Technological developments in nuclear imaging modalities and advancements in therapies like RPT for different cancers and new methods of harvesting raw materials are playing a large part in the growth that we're witnessing. Because we aren't Bruce Banner, working with radiopharmaceuticals requires a lot of safety. Hot cells, among other measures, do an excellent job of providing protection. Hot cells are shielded nuclear radiation containment chambers that are used to process and manipulate radioactive materials. Manipulators work in tandem with the hot cell by maintaining the protection provided by the hot cell while allowing an operator to interact with the items inside. Because manipulators can function with precision similar to our hands, wrists, and arms, basic tasks such as lifting objects out of transfer containers, opening containers, weighing test materials, or filling and capping a vial can be performed rather effortlessly, as you can see in this video. The video demonstrates some nice precision and the user experience, so I'm going to let this continue to play out before we move forward. So far, we've only scratched the surface of what a telemanipulator is and what it can do. For starters, there's no sense in purchasing something if you're not going to utilize it as much as possible. The same is true of a hot cell. So you're going to want that manipulator to cover as much space as possible. This is achieved by performing these basic motions: back and forth, X motion; in and out, Y motion; and up and down, Z motion. Depending on the style of manipulator, wrist-like motions can also be achieved, such as rotating, also called azimuth; flexing, extending, called elevation motion; and twist motion. It's not enough to just bump into stuff. So manipulators can also open and close their tongue to grab items. One of the more fascinating aspects of manipulators is that they typically have minimal electronics due to the harsh radioactive environments that they function in. So pulleys, cables, and tapes do the majority of the work. Manipulators can be categorized into two buckets: ball manipulators and master slave manipulators, also known as command remote manipulators. Let's start with ball manipulators. They're installed straight through the hot cell wall and are composed of a 1 meter long shaft mounted on a shielded ball joint. It's a straightforward approach, no pun intended. The ball manipulator is built with few moving parts and has a low price entry point. They will also have a more limited coverage area and weight capacity. As you may recall earlier, we talked about those wrist-like movements. This is a manipulator style that's limited in this regard, making it more difficult to perform complex tasks. The limitations in coverage area, weight capacity, and movements can create more strain for the operators. Command remote manipulators are typically installed through the hot cell wall overhead, but some models also drop into the hot cell through its ceiling. Natural motions of the hands at the command end are reproduced identically at the remote end with minimal effort and high precision. Command remote manipulators are ideal for dynamic, sensitive, and detailed tasks. They're available as a one-piece telemanipulator or a three-piece telemanipulator. In radiopharmaceutical production, the one piece is more commonly used, so we're going to focus on that type for this discussion. The one piece manipulator is composed of the handle and control arm that sit in front of the operator. Then the through tube passes through the hot cell wall and connects to the remote arm inside the hot cell. The entire unit terminates at the wrist or tongue or jaw. Stainless steel tapes and cables are used to transmit motions from the command arm to the remote arm in continuous closed loops. A little later in the webinar, we'll discuss some ways to optimize your manipulator. So CRL's answer to radiopharmaceutical production can be found with our G line. The best place to start is with our model GLD. The one-piece GLD telemanipulator is a compact, lightweight remote handling solution designed for use in small working areas. The GLD features a full range of customizable features, making it easy to adapt to operator preferences and able to evolve as needs change over time. Its smooth, continuous movement, wide range of motion, and strong construction produce intuitive ergonomics. The durable GLD was engineered for effortless maintenance and is backed by CRL's global on-demand support. The GLD telemanipulator is a reliable sidekick with the versatility to take on the diverse tasks required for your critical work. The GLD-R is a lighter version of the GLD with a smaller diameter for the through tube. This diameter is convenient when replacing manipulators made by some other manufacturers. The GLD-C utilizes more cables in place of tape, which provide more longevity and continuous production. And the GHD is the heavy-duty version of the G line. It's engineered for larger hot cells and features electrical X and Y indexing to improve comfort and reduce strain. More on indexing in a bit. So when buying clothing, you use sizes, measurements, maybe even some tailoring to get a good fit. The same is true when buying a manipulator, and this is something that CRL takes very seriously. We want your manipulator experience to feel as natural and comfortable as possible. And that starts with selecting the right model, as well as sizing and shielding it to the specifications of the hot cell. In this regard, we encourage you to get our team involved as early as possible to assist with this process. The ability to optimize your manipulator to your specific duties and preferences continues with the features and options that you select, and even extends beyond the assembly of your purchase with services like installation, training, servicing, and technical support, both on-site and remote. So let's take a deeper dive into some of these topics, and we'll start with selection. CRL will work with you to learn some initial information that will help match you with the right manipulator. We'll cover criteria like handling capacity and radiation shielding requirements, and some others. Then we'll work our way into some hot cell dimensions. Rather than limiting you to preset sizes, CRL will gather this information to tailor your manipulator. This worksheet shows some of the most relevant info that will factor into your selection and configuration. Items like cell wall thickness and hot side working height and length will get looked at, as well as cold side dimensions, because they can be important as well. They have a lot to do with installation and user comfort. So next, CRL is going to work with you to assess several options for your manipulator to meet your specific needs and preferences. We'll touch on a couple of these that are most relevant to your work. Various tongue jaw options are available to handle different shapes and types of loads. And CRL can provide a variety of handles based upon user comfort and efficiency. Pistol grip and opposed grip, or pinch grip, are two common styles. CRL's Versa VR8 is our newest style that features our most advanced ergonomics and is highly customizable. Telemanipulator indexing lets you change the relationship of the command and remote arms to improve in-cell reach and operator comfort. For example, manual Y indexing will allow the operator to move the remote arm 15, 30, and 45 degrees while the command arm remains vertical or at 0 degrees. Once engaged, operation can resume and the indexed relationship will maintain until you reset it. Motion locks are used to lock the manipulator in a position, allowing it to hold an object in space without requiring an operator. Motion locks also assist with installation and the removal process. Booting is used to restrict airflow into the hot cell and to protect the remote arm from contamination. It's available by CRL as polyurethane, CSM coated polyurethane, or PVC sleeve material. For one-piece models, the tongue assembly or jaws can be disconnected and the entire manipulator removed with the booting still in place and no loss of containment. So the last option we'll look at here is the load hook. It's a remotely removable device that hangs from the end of the manipulator remote arm. The hook is used to pick up objects that are normally too heavy or awkward to handle in the tongs. So the only thing missing here is a cup holder. And as you can see, there's several ways to make your manipulator feel like an extension of your hand and an extension of the safety provided by your hot cell. So we'll talk more about this in the next segment. So now I'd like to invite Rob Weber, our applications and proposal manager, into the webinar. There you are. Hey, Rob.
Hello.
Thanks for joining me.
No problem.
So Rob, a couple minutes ago, we touched on the selection process. I was hoping, if you don't mind, if you could expand on the selection process a little bit and just speak to some of the critical areas that would be helpful for our attendees to pay close attention to the next time they're making a selection.
Well, obviously the most important thing is the work that's done inside the cell. So it is really important to make sure that the work being done and the manipulator itself match each other. both for capacity and handling requirements, and particularly space and reach requirements. It's important that the manipulator be able to reach what it needs to reach in the proper position and the proper orientation, and to do so with the operator in hopefully a comfortable position. It's certainly possible to have the operator in an awkward position if you're doing some extreme reaches, and that's why some of the features of manipulators can help to alleviate that. And that's where the motion indexing is important. And the other thing that's really important for the operator is to select a comfortable handle. We do offer a number of versions of handles. It's been my experience that once an operator gets used to a particular handle, it's difficult to get them to try something new. So it's always good to give those a try and make sure what the operator is using is most optimal for what they're doing.
Awesome. Thanks, Rob. So, you definitely covered a lot of things there. Is there anything else that maybe some less critical items? I know you touched on the handle there, but can you think of any other type of items that are usually chosen during the selection process that would be a little less critical, but maybe make things a little bit more comfortable or a little bit more efficient for an operator?
I think the primary thing there is at the very business end of the manipulator, at the grippers and the fingers that are used on them. We certainly have general purpose jaws that we call them, or fingers, that are typically supplied with them. That's for just handling a variety of equipment. But we also make a number of special purpose jaws. If you're gripping a particular type of object that's round or spherical, or just something that's not easily handled in a general purpose jaw, it helps a lot to have something that can do that. In particular, cylindrical objects, we have a variety of jaws that are used for special things like that, and that can help the process just be a little easier to operate.
Okay, great. So how about, can you recall any cautionary tales that may help our attendees when they're making a selection? Some things that maybe that would help steer them away from they themselves becoming a cautionary tale.
Again, the biggest thing is matching the work and the hot cell to the manipulator. It's not pleasant when a manipulator is spec'd, it's built and delivered to a customer, or particularly to a hot cell maker, and it turns out it's not a good match. If it either doesn't mount properly, it doesn't fit properly, that can be a real problem. It's occasionally we have to go back and make some kind of invasive modifications to make an existing installation work, where it certainly could have been avoided with just proper planning up front and working with us at the beginning to make sure that what we're going to provide will fit properly and do the job. So that physical planning up front is very important.
Yeah, thanks. So we'll move on a little bit from the selection process. Let's talk about manipulators a little bit more broadly. They've been around for a long time, but can you speak to any notable advancements that you've seen in recent years with these products?
The basic technology for a manipulator, again, it's been around since the 1950s. That really hasn't changed a lot. It's really the package that those functions come in. We've certainly had a much greater focus on ergonomics recently. When these operators are using these manipulators for 8 hours a day, 5 days a week, that can be a problem ergonomically, but we've spent a lot of time in the last few years developing new handles, things that are more attuned to their hands, and especially to a variety of hands. So many of our handles are much more adjustable and customizable to a particular operator. Some of them are even removable quite easily. So a particular operator with a particular hand size can have a pair of handles that is attuned to their specific hand size, and they can possibly just take that and put it on a manipulator for their shift, and when they're done, they take it off and the next person brings their own on there. So ergonomics is a big deal. We've definitely worked on making sure that our manipulator designs are more robust. They obviously are maintainable, but the less maintenance you have to do, the better. So we've certainly been concerned about maintainability and uptime and reliability, and we've made some changes in manipulators to improve that. And then another big push lately is for those manipulators with electrical indexing. We've done a lot of work with modernizing our electrical systems and making sure they're certified and able to meet all safety standards around the globe.
That's great. Thanks. So this may not come as a surprise to you, but occasionally products are used in ways that they're not necessarily intended for. Uh, do you have any advice or tips or recommendations that you can make for our audience that could help steer them clear of some common misuses?
Don't use them as a hammer. I've seen that, and it's just not good. Yeah, you can do some heavier duty things, but they're still lighter duty laboratory equipment and need to be treated as such. So I've seen some pretty interesting looking business ends of manipulators where they're used for things that they're really not meant to be used for, and being a jackhammer in particular. And then maintaining, just staying within the capacity limits. These manipulators have a capacity limit. It's intended that you don't lift and handle anything larger than that. Maybe you can, but by doing so, you're probably reducing the life of the equipment by doing that. So if you need to do something a little heavier duty, use the load hook accessory that we talked about earlier. And if it goes beyond that, the manipulator is probably not the right piece of equipment. You may need some more heavy duty handling piece of equipment in there. Although in the radiopharmaceutical space, that's really not very typical.
Yeah.
And then just for the operator to regularly just take a quick look at the manipulator, make sure that some of the operating equipment on it is in good shape. If it has cable driven motions, make sure they're not fraying. It just takes a little bit of observation to see if there's anything that might be getting frayed, or a tape that gets nicked, or if it's getting sloppy in operation, maybe it's time for a little bit of maintenance and refurbishment. So catching that ahead of time goes a long way with keeping the downtime short and the equipment operating as much as possible.
It's good stuff. I think if there's any major takeaway from this entire webinar, I think not using it as a hammer, that might be, a pretty solid one. I like it. So, all right, Rob, you have plenty of experience, which is really impressive with this product line. If we could tap into that a little bit, if you don't mind, could you speak to maybe a specific project or two that you've worked on that really highlights, CRL's capabilities?
Well, my favorite ones are the kind of the ones that are off the beaten path a little bit. Of course, my favorite was working on the Hollywood movie set and putting the manipulators in a movie. And that was probably one place where they didn't really use them what they were meant for, but that's okay. It was just make believe. In addition to just having a standard gripper on manipulators, we've had a couple of interesting things where we've maybe mounted a camera on the end of a manipulator. So if an operator for some reason couldn't get good vision on the work they're doing, if it was at an extreme position or something, the camera and a monitor could be used to monitor the work. We had one where instead of a gripper, we had a dry ice gun on the end of it, and somebody was using it as a cleaning device.
Okay.
Rather than just grabbing something. So that's kind of interesting. But then some of the, it's just fun to see the applications for these at least one national laboratory that's doing cancer therapy research. They're using our manipulators to do that kind of research. And then some of the radiopharmaceutical production and end users at hospitals. They'll have to do some specialty things once in a while, and it's been fun to develop special purpose grippers and jaws for what they need to do. So again, a wide variety of things to do. And one of my favorite manipulators is the one that the remote arm was about 20 feet long. And they really had to reach some very extreme things with that one, but we had the capability to do it. So that was good.
That's pretty cool. from the movie set to cancer research. That's cool stuff. Thanks for sharing that.
Mhm.
So that is actually going to round out our roundtable discussion. So again, I want to thank you very much for being a part of this, Rob. Really, really impressive insights. So please stick around.
Mhm.
We actually are going to pivot and we're going to move into our Q&A session. If for our attendees, if you have any questions that you have not yet submitted through the Q&A function, please do that now. We're going to do our best to get to as many questions as possible while we're live. But if we can't get to anything while we are live, we'll definitely make sure to follow up with you offline. I'm going to invite Sheena Shriver, who is our communications and marketing leader, to jump on to help us out with this Q&A portion.
Hi, everyone. Thanks for sharing your insights and your experience with us, Rob. That was great to hear all of that. The hammer was definitely a good takeaway, too. That's great. It looks like we don't have any questions in at the moment. If you have any you'd like to submit, feel free to get those in. We can wait a few more minutes. Make sure we
Yeah,
get
we'll wait a little bit here. And folks, you know, don't be shy. If there was something that Rob spoke to here just a minute ago that you'd like, you know, to elaborate on, please feel free to do so. We'll hang on for another minute and then we'll continue moving forward and close this thing out shortly.
Hey, Rob, you must have been really thorough. There aren't any that have come in yet.
All right, that's good.
We have one, Kyle.
Okay.
What is the most popular manipulator type?
Rob, I'm going to let you take it. You're the expert.
Well, it really depends
still have
on,
Rob
on the
unmuted?
application. Certainly, again, in the radiopharmaceutical type, the remote command type, and our Model G family, which is the smaller compact version of a manipulator, definitely most common in the radiopharmaceutical space with the smaller hot cells and lighter duty work. Then we start getting into larger manipulators. Those goes into large hot cells where you'll see those in nuclear laboratories, people doing nuclear materials or nuclear fuels research. That's where the larger manipulators come into play. And thankfully, both of those sectors are quite active.
Thanks, Rob.
Thanks, Rob.
Kyle, that'll round that out if you want to close out the Q&A session.
Perfect, I will. Thank you. So I want to thank everyone again for their time here today. We covered a lot. Started things off with the origin of telemanipulators. And then we moved into their connections to the radiopharmaceutical industry and how CRL's G-line can help bridge that, bridge those two categories. And then we covered some ways to customize your telemanipulator. And with the help of Rob, we dove even deeper into customizations and selections and some specific projects that CRL has been a part of. So before I close this out, I really want to encourage everyone to reach out, let Rob and myself know if we can connect with you one-on-one or set up a meeting. We're also open to setting up demonstrations, individualized demonstrations. So please don't be shy, reach out to us. Also find us on LinkedIn. Be sure to follow CRL. That way you can stay up to date with any CRL news. So again, thank you again for being a part of this and have a great rest of your afternoon.